In this video, we're going to look at quadratic equations, and in particular in the variations you get on those questions. So none of the question types in quadratic equations are in themselves particularly difficult with a bit of practice. It's the confusion between the different questions, which are very similar, that tends to cause the problem. In fact, I see students all the time confusing them, muddling them, answering the question with the wrong technique sort of thing. So there really are only three techniques to look out for. So one is where you're given a quadratic equation. Remember, that's an equation, it's got an x squared in it. So a quadratic equation, and they ask you to solve it, but they make a reference to decimal places or significant figures. That essentially tells you it's a calculator question. That's going to be the quadratic formula, like no question about it. This one is very similar. It's a quadratic equation, and it does ask you to solve, but there's no reference to decimal places. So whilst you could use the quadratic formula for that, that's probably going to be in the non-calc paper, and it's going to ask you to do it, well, not ask you, but it's kind of suggesting to do it by factorizing. Because if you factorize, you're not going to get decimal solutions, you're going to get whole numbers. So those two are very similar, but completely different techniques. The third one's not asking you to solve the equation, but a lot of students will solve it, or they'll do something more aligned with solving than they will with actually answering the question, which would be to determine the nature of the roots. The nature of the roots, remember, means how many roots are there? 2 real roots, 1 real root, or no real roots. So in this case here, the clue is the decimal points. That tells you you're going to be using the quadratic formula. Remember, that's on the formula sheet, so you don't need to memorize it. The point of this video is not so much to go through the technique. The point is to be able to learn how to separate these out. So because I've seen decimal places, that would tell me I'm using this formula. It would also probably tell me that this doesn't factorize. If I tried to put that into 2 brackets, I would find that it's probably not going to work, because that's how the questions tend to be designed. So I would need to go here to my equation and say, right, the 2 is the A value, the 5 is the B value. Being careful with negatives here, the C is -4, and then I would just substitute those values in the equation, and then just go blah, 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 and carry on and finish the equation. Finishing off is normally easy enough once you've decided that it's a quadratic formula. In this case, however, although I'm being asked to solve, no reference to decimal places or significant figures, that tells me I should be able to solve it by factorizing. So in this case, it's a trinomial, so we could factorize into 2 brackets. This one does factorize with a -8 and a -3, and then you could go ahead and separate that into 2 little equations like this, and then you would get the 2 solutions like this. Sometimes actually in a question like this, they will say solve algebraically, and if they say algebraically, then they mean by factorizing, not by a numerical method, which is what the quadratic formula is. So again, not too worried about the solutions or the method, more focused on how to distinguish which technique to use, no reference to decimal solutions. In the third case, we're looking for the nature of the roots. So remember, that is related to the quadratic formula, but just this part, the discriminant, the b squared minus 4ac. So as soon as you see nature, you've got to think in your mind, you've got to associate that with b squared minus 4ac. Remember, you don't need to include the square root, just a bit under the root. So again, you would go about this by identifying your a, b, and c values. So a is 2, b is 4, c is 5. Plug those into the formula. 4 squared is 16 minus 4 times a times c, which is 5. So that's 16 minus, what do we have there? 20, 40. So that's going to come out to be minus 24. Because it's come out to be negative, that would be no real roots. So the solution there would just be no real roots. If it come out to be positive, then it would be 2 real roots, and if it came out to be 0, it would be 1 real root. But again, the key there is nature. So I see a lot of students saying the nature of the roots question, and they interpret it as this, finding the roots, finding the solutions, or this question, and they interpret it as nature of the roots. The key is to not get them confused. So hopefully that will help keep those different techniques separate in your mind.